Alright, so we're still really kind of working on learning target 5.2, finding the 6 trig functions using triangles. Alright. One of the examples that I want to start with today is, I want to give you a picture of a triangle, a right triangle, and we're going to go, this is 8, we'll say this is 5, we'll call this angle A, and what I want you guys to be able to do is find all 6 trig functions of angle A. Sine, cosine, tangent, who remembers what the other 3 are?
Cosecant.
Cosecant of A. Secant of A, good job.
And then cotangent.
Cotangent of A, nice job guys.
We're on the ball.
Okay. So we want to get all of these ratios written out. But as of right now, can we rattle all 6 of those off?
No.
No, why?
If you need to do like diagram and find out.
We got a missing side here, okay? So we can't really tell what the ratio will be, the sine of the angle A, cosine of A, until we figure out that missing side. You guys are kind of on top of it there. You said, use Pythagorean's theorem. So if you think of that as like your x squared plus 5 squared equals 8 squared, right? So x squared plus 25 equals 64. Is that going to be 39?
Yeah.
X squared equals 39, so x equals, very simply, the square root of 39. I don't know that you can simplify that.
You can't. I've already tried. You can't. I don't know.
Oh, yeah. I thought you meant in kids' sizes.
He's already tried. He's
Square root of 39, can we simplify that?
Nope.
No, because 3 times 13, 39, there's not any perfect squares that go into 39, so we'll leave it as a square root of 39. Yeah, I don't need any of that, so take as much as you want at all.
Alright. I can take it.
Alright, so now we have all 3 sides of the right triangle. Now can we do all 6 trig functions?
Yep.
Okay. What will the sine of angle A be then?
5 over 8.
Alright, Derek? 5
Sorry.
over 8.
Sorry.
Well, I'm just kind of doing a little check around the room, make sure everyone's kind of feeling good about this, okay? Because sine of an angle is opposite over hypotenuse, we got 5 over 8. Cosine, Nick?
Square root of 39 over 8.
Yep, square root of 39 over 8. And that's just how we're going to leave it when we have those radicals in there. Okay, we don't need to reduce that or do anything different with it. Now, if we get a radical in the denominator, then we got to start doing some stuff with it. Okay, but the cosine of angle A will equal the square root of 39 over 8. Okay, tangent, Dakota.
5 over 3 square root of 39.
Okay, to start with, yep, we'll write 5 over the square root of 39.
Oh.
Okay? Kind of in general, we don't like leaving radicals in the denominator of fractions. How do we get radicals out of the denominator?
Multiply the same radical at the bottom and top, and then it'll just get rid of the radical.
Yep. Multiply the top and the bottom by that radical. So, on the top, when you take 5 times the square root of 39, you simply just get
5 square root of 39.
5 root 39.
And you get 39 on the bottom.
And on the bottom, the square root of 39 times the square root of 39 is just nicely 39. Okay? If you're having trouble understanding why that is, think about the square root of 5 times the square root of 5. The square root of 5 times the square root of 5 would be the square root of 25, which would just be the number 5. So the square root of x times the square root of x would simply be x. Square root of 39 times square root of 39 will give you just a nice normal 39. You can't reduce that any further. because this 39 is underneath the radical symbol, this one is not. You could reduce it if both this 5 and that 39 were divisible by the same number. Then you could reduce the fraction further. But as of the way it is right now, 5 root 39 over 39. Okay? All right, cosecant. Cosecant is the reciprocal of which one? Sine. Cosecant is the reciprocal of sine. Okay? So if the sine of angle A is 5/8, the cosecant of angle A will be 8/5. Okay?
That was really cute.
Mm-hmm. 8/5 for cosecant. I'm running out of room here. I'm going to put cotangent over here. Okay. Secant is the reciprocal of, anybody?
Cosine.
Cosine. Okay? Reciprocal of cosine, well, cosine was root 39 over 8, so the reciprocal is 8 over root 39.
And then you got it.
And then we got to simplify it. Yep.
So, yes, we all know what to do.
Here's the
8 root 39 over 39. Can I skip that part now
Yep.
that we kind of know how to get radicals out of the numerator? I know we've done that a lot. So 8 root 39 over 39. Okay? And last one, cotangent. Cotangent is the reciprocal of tangent. Let me give you one piece of advice here. Okay? Sometimes after people have already done tangent and they see this is the answer, then they want to reciprocal that answer. That's fine, but you just made yourself a lot of work. Okay? Remember, the tangent was equal to 5 over root 39 to begin with. If we reciprocal 5 over root 39, we get root 39 over 5, and do we need to simplify that at all? No. So I'm saving myself the simplification work, okay, by just doing the reciprocal of the tangent here. Or really, if you look at the picture, remember cotangent is the reciprocal of tangent. Tangent is opposite over adjacent, so cotangent would be adjacent over opposite. So root 39 over 5. Would you eventually get to that, even if you did the reciprocal of tangent? Sure, you just made yourself a little extra work is all you did. Okay?
Okay.
So, if I give you two sides of a triangle and ask you to find all 6 trig functions, can you do it?
Yes.
Okay? What's the first thing you'll have to do?
Make sure it's right triangle.
Make sure it's a right triangle and do Pythagorean's theorem. Yep. And then you should be able to rattle off all 6 trig functions.
Kind of funny though, because you said if I give you a right triangle.
Okay. Alright, so that's kind of part of it. Let me do another example here. Oh, these are pretty basic. You'll have some problems like this. If the secant of theta equals 4/3,
What is it?
find the cosine of theta.
That's theta.
Okay? No. Theta is a variable that we use a lot in trigonometry. All right? Oops. Why is that off?
So it'd just be 3/4.
Right? This is the Greek symbol theta. All right? It is just a variable that we use a lot in trig. It represents an angle. We could use x, we could use y. We've been using a and b. It doesn't really matter. It's just this is the one that shows up quite often in your textbooks. And yeah, I kind of just completely glazed over the fact that you guys probably haven't seen that before. But that's all that it is. It's a variable, okay? And we use it a lot of times in trigonometry. Other Greek symbols, sometimes you'll see used alpha, all right, beta. Sometimes you'll see that used too. It's like the Greek symbol for A and B. All right, A, alpha, B, beta. All right.
So we got A and B from?
Yeah, from the Greek alphabet. I'm pretty sure is where we got all that stuff from. Pretty sure. Don't quote me on it. But I'm pretty sure that's. Yeah.
I don't see how it looks like it. Maybe a lowercase.
A little bit. Lowercase, yeah. So anyway, Theta is just a variable. These are also variables or letters, really, is all they are. Anyway, back up to the problem. If the secant of theta is equal to 4/3, now we don't even have a picture here, right?
You don't need one.
But do you need one? Why not, Derek?
Because it's just a reciprocal of, or secant is a reciprocal of cosecant, so you just.
Yeah. These are nice enough. The biggest thing on these is you recognize that these are reciprocals of each other, so you don't even need a picture. Okay? You could draw a picture to go with it in this case, but in this, you don't need it, because if the secant of some angle is 4/3, the cosine will be the reciprocal of that. So in this case, the cosine of theta would equal 3/4. Okay? What questions do you guys have on that problem?
How do you know it's right triangle?
Okay. That is, we are assuming that for the time being. But that's a very good question, Dakota. I did not write that up there. For right now, you can assume things are right triangles. Okay? Even if it doesn't say so. Alright. Let's see. Should all be good there. Let's plot the point -3, 5 on a graph here in a second. And then we're going to make a right triangle with hypotenuse through that point, and then we're going to find the 6 trig functions. Okay? I'm going to go to a new slide here so I can draw the picture, but I'll make sure you guys get the directions down.
Is it?
Okay, so here's kind of what that's going to look like. So -3, 5. There's our hypotenuse from the origin. Go down to the x-axis. And we'll call this angle theta right here. Okay. Well, if this is the point -3, 5, you know 2 lengths of the sides of that triangle, right? -3 or 3 if you're just talking length, but I'll go, well, wait a minute, we haven't done, yeah, because we're doing that, I'll better keep it negative. So -3 and then 5, right? So if this is the point -3, 5, you know, this is -3, this is 5 on an xy coordinate plane. Figure out the hypotenuse, Pythagorean theorem, right?
Mm-hmm.
This squared would be 9, this squared would be 25, 9 and 25 make 34, so this would be the square root of 34.
Yep.
You guys with me on that? That squared is 9, that squared is 25, 9 plus 25 makes 34. This would be the square root of 34. Okay? Now, could you again rattle off all 6 trig functions? I think so.
Yeah.
Okay? What will the sine of theta be?
5 over 34.
5 over root 34 and then simplify, right?
Yeah,
Okay?
Why do we need to put this on a graph?
What's that?
Why do we need to put this on a graph?
Because we'll end up doing a lot of things on the Cartesian coordinates, on the XY plane too, as far as trigonometry is concerned. And we eventually get into a unit circle and periodic functions, and so I want you to be familiar with it on a unit circle as well, okay? So you'll see more as we get into it, but.
If we can just simplify it in our heads, can we just write it off?
Yeah.
Okay.
So that'll be 5 over root 34, which you guys know is 5 root 34 over 34. Cosine, adjacent over hypotenuse, and so on, right? Just for the video's sake, I'm going to shut this down. Questions?
So, like, when you're doing cosine or anything using the -3, would you use that 3?
Use negative. Anytime we put it on, good question, anytime we put it on graph paper, we have negative x values or negative y values, you got to use those negatives at that point.
That's a negative.
Okay, so like the tangent would be
Well, but the length is 3.
5 over -3 or something like that.
Yep, the tangent of theta in this case would be opposite over adjacent, so my answer would be negative 5/3, 5 over -3. I mean, however you want, wherever you want to put that negative, you know, it's fine with me, Jake. But I like putting it just in front of the fraction. I don't like making just the top negative or just the bottom. That's just a preference of mine.
Oh, so it has to be negative?
But yeah, because 5 over -3 is going to equal a negative number, right?
Yeah.
Cosecant.
And
I thought it was
once
more
you
like a distance, so wouldn't it? Why would it just be 5 over 3? Just for the graph, it's.
How do you write cosecant?
No, I'm.
How do you write cosecant again? What's the abbreviation?
CSC.
CSC.
CSC. Yeah. So again, drawing the picture, making the triangle, don't forget your negatives, and you can do all 6 trig functions that way too. Right? That's pretty much it for the types of problems you're going to do. I got a little bit more, but I don't need to probably put it on video, so.